when we have a trinomial that's written in standard form, it's ax squared plus bx plus c. This first coefficient is a, the x coefficient is b, and the constant term is c. The discriminant we would find by doing this, b squared minus 4ac. So for example, if I have, let's say, x squared minus 4x plus 7, something like that. If I do the discriminant, then I would do b squared, which is negative 4 squared is 16, minus 4 times a times c. And I would get 16 minus 28, which is going to give me a negative number. So here are the outcomes when you do the discriminant. You're either going to get a positive perfect square. Sometimes you'll get 0. Sometimes you'll get a positive number, but it's not a perfect square. So we'll just say a positive integer. And then sometimes you'll get a negative number. So if you get a positive perfect square when you do the discriminant, that means that there is one root, which we haven't talked about roots, but that means that actually, positive perfect square means that what we're going to use it for is we know that it can be factored. And when you factor something, that means that you're either going to get 1 or 2 answers. Because if we have something where it factors to this, then we're going to get 2 answers, but they're going to be identical. If we get something that factors to this, oops, that should be a 4, then we're going to get 2 answers and they're going to be different. So if you get a positive perfect square when doing the discriminant, that means that it can be factored. If you get 0 when doing the discriminant, that means that it can also be factored. And you're going to have this situation where you only have one root or one solution. I mean, you're going to end up with 2 binomials, but they'll be identical. So we call that one root. If you have a positive integer, that means it cannot be factored. And if it cannot be factored, that means you're going to have irrational roots. And we'll look at ways to solve those. And then if you get a negative, that means that it also cannot be factored. Without using I. If you use I, then sometimes it can be factored, but you know for sure that if your discriminant is a negative, it's going to be an imaginary number or a complex number that you would have for your root. Okay, so just to recap, if you do this discriminant and you get a positive perfect square, or if you get 0, that's what we're looking for to know if we can factor it. If you get one of these 2, it can be factored. If you get a positive number that's not a perfect square, or if you get a negative, then it cannot be factored. Now, the negative one can sometimes be factored using I, but you know for sure that it's going to be a complex number for your root. Okay. All right, so let's factor these. Let's use the discriminant test to see if this can be factored. So this is my A, this is my B, right, -1, and this is my C. So the discriminant is B squared minus 4AC. So I would get B squared would be -1 squared minus 4 times 2 times 3. That equals 1 minus 8 times 3 is 24, which is -23. This cannot be factored. It's prime. All right, let's look at, well, actually I shouldn't say that it's prime because it may have a solution that's not a real number. It may be an imaginary or a complex root. So we'll just say that it cannot be factored. All right, let's look at this next one. It looks like I've got some multiples here. It looks like multiples of 3. So I'm going to start by taking a 3 out. So if I factor out a 3, I'm left with 2a to the 4th plus 9a minus 18. Let's use the discriminant test to see if it can be factored. So I've got A, this is my A, this is my B, and this is my C. So if I use the discriminant test, I have B squared minus 4AC, which would be 9 squared minus 4 times 2 times -18, which is 81 plus, let's see, 8 times 18 is 144, and 144 plus 81 gives me 225. So now you can check on your calculator and see if 225 is a perfect square, but you will find that it is a perfect square, which means that this can be factored. So let's factor it. Now I'm going to show you a shortcut, a trick, okay? We're going to start off the same way by multiplying these two. 2 times -18 is -36. We need to find two numbers that multiply to be -36 but add to be +9. So I've got my factor pairs. And I want one of them to be negative, and they have to add to be +9. So it looks like I'm going to use this pair. All right, now this is the step where normally you would replace this +9 with a -3a and a +12a, and then you would factor by grouping with the first two terms, group the last two terms like we've done for every other example in this lesson. But I'm going to show you, just as a special treat for those of you who are actually watching the videos, I'm going to show you a shortcut. So we've got a 3 out in front, but we'll come back to that later. This is the shortcut. The shortcut is that you take A over. Just remember that. A over. So our value for A is 2. So I'm going to do 2 over each one of my numbers that I got here. So I'm going to have 2 over negative 3 and 2 over positive 12. I've reduced the fractions. 2 over negative 3 cannot be reduced, so it stays. 2 over 12 can be reduced. It reduces to 1 over 6. The numbers on the top and bottom tell me the numbers to fill into my parentheses. So if I have a 2, that 2 is going to go right here. The negative 3 is going to go here. The 1 is going to go here. The 6 is going to go here. And since I've got a, oh, and there's a typo. This should have been a squared. Since I've got a to the 4th, then I'm going to fill in my variables as well. So let's do the numbers first. I know that a 2 goes here, and a minus 3 goes here. I know that a 1 goes here, and a 6 goes here. Then I just fill in the variables. A to the 2nd, a to the 2nd. And that's a plus, because it's a positive 6. All right, so that's a shortcut. The shortcut to plugging everything, to splitting the middle term, which is what it's called, we split that 9 up into negative 3 and positive 12, and then we factor by grouping. Instead of that, you can do a over, and you get 2 fractions. You reduce both of the fractions completely, and then the numbers in those fractions tells you what numbers to plug into those spots in the parentheses.